All right. Good morning. Thank you for joining us for another session of Power Hour. My name is Eob Hailamariam. My co-host today is Johannes Hailamariam. Our topic for today's Power Hour is Orion I/O applications. Looking at our agenda for today, we'll start out by doing an Orion I/O hardware overview. We'll then get into the different types of cards that are available on the Orion I/O. In particular, we'll dive into a little bit more detail on the analog input flex card, the discrete input, this discrete 8 discrete output combination card, and the 16 discrete input wedded card. We'll discuss what input and state inversion is on the Orion, how to accomplish that. We'll look at some of the different Ethernet port options that are available on the Orion I/O. In regards to IRIG-B, I'll touch on time synchronization options on the Orion I/O. I'll wrap up with a brief explanation on retrofit applications using the Orion I/O. At which point Johannes will go over the Orion I/O configuration and do a couple of demonstrations and go over some commonly asked questions in regards to the Orion I/O. All right, let's get started with the overview. The Orion I/O is a high-density I/O module that contains up to 64 discrete inputs or up to 64 discrete outputs or up to 32 analog inputs or a mix and match. It's got a unique touchscreen front display that we'll look at and can be used in an assortment of legacy RTU retrofits. Some of the key features of the Orion I/O are that it has an advanced LED interface that gives the user point details and simplified troubleshooting and commissioning. In addition to server protocols, it also has the ability to talk to other IEDs using client protocols. The I/O has a full set of cards to cover transmission and distribution applications. It also simplifies NERC SIP compliance by having the same firmware, security, and configuration tools as the Orion RTU. For larger applications, multiple I/O modules can be configured with one configuration file that is sent by the Orion RTU. We call this process our application cascading, and we'll briefly go over that later. And the Orion I/O can be used in a number of retrofit applications. Some of the retrofits that we've assisted customers with so far are D20s, Telvents, Landis & Gear, and System Northwest RTUs. If we look at the front of the Orion I/O, what you'll see is a 4x20 character LED display on the left-hand side that allows users to see user-defined details regarding any one of the contacts on the Orion I/O. This includes timestamp information when a contact has changed statuses. And on the lower left corner, what you'll see is a serial USB maintenance port. That's going to allow the user to access into the Orion I/O for loading configuration files, change settings of the Orion I/O, or allow for troubleshooting. The rest of the front display contains touch-sensitive buttons with LED indications. So if you look at the buttons, below the LED display, there are buttons you can touch that can indicate if a configuration file is active on the unit, or if there's an alarm on the Orion I/O. If you touch the time button, the LED display will indicate if the Orion I/O has a quality IRIG-B source and what the current time and date are. The display button there allows user to see what kind of cards are populated into the different slots, as you can see there. If you hit it a second time, the LED display will actually display the firmware, the serial number, and the configuration file that's loaded onto the Orion that's activated. If you actually hit that same display button a third time, a user could view user-defined details, like for example, an IP address of the Orion I/O or maybe the DMP address. So you have some flexibility there. Hitting it the 4th time allows the user to do a quick LED test just to make sure all the LEDs on the Orion I/O are functional. The rest of the buttons that you see on the right side are for statuses. So based on how you have this Orion I/O configured, whether you have cards in slots A, B, C, or D. So the first card, one thing I do want to point out here is the first card that you have on this Orion I/O is a card A. Notice that it's on the bottom. So the other cards B, C, and D are stacked above it. Notice to the right of card where it says A, you have 16 statuses. And so those statuses are going to be associated with the, whether it's a 16 discrete input or 16 discrete output. So you also get LED statuses in the center. So one thing you'll notice is the discrete inputs will have green LEDs, discrete outputs will have red LEDs, and the analog inputs will actually have amber, as you see there, when they're illuminated. Now on the flip side, if you look at the back of the Orion I/O, what we'll find are the terminals for all the status boards. So on the left-hand side, notice that each of those connectors are actually not only, they're angled. So one of the things that I want to point out is that they're angled, so it makes it a lot easier for wiring purposes. So they got a 45-degree angle on both the bottom and the right-hand side, so that actually gives you a little space there for labeling. So notice by standard, we label those connectors on there so that you know exactly where those, you know, if it's a card A, 1 through 8, exactly where that wires into. Another thing to notice there is on the right, towards the middle area, you'll see indications of how those cards, how this Orion I/O is populated. So whether it has a discrete input. So if you look here on the card A, notice there's a discrete input on the first slot. If you look at card B, notice there's a discrete input wetted card on card B. If you look at card C, you'll see that there's a discrete output, normally open, normally closed contact card there. And then if you look at slot D, there is an analog input card that's populated there. All right, so these indications are going to be based on how this Orion I/O was built when it left our facility. The next things I want to point out are towards the right-hand side. What you'll find there are going to be your alarm contact for this Orion I/O. You will see your power supply connection. You'll see your power connections. So notice there's 2 positive, 2 negative, and 2 ground connections. In terms of power supply, the power supplies on the Orion I/O, you have an option of a low voltage, which is 12 to 24 volt option, to a 48 to 250 volts DC option. AC or DC option there. On the bottom, you have an I/B input port. So notice it's just a terminal where you can wire in the negative and the positive signals for an I/B signal. You also have your serial connection. Notice instead of a DB9, it's kind of more of a where you're wiring the wires into a terminal. With this serial port, you could do RS-232 or RS-485. That's going to be software selectable in the web interface configuration. Next is going to be the Ethernet port. So to the right of that, you'll see 2 copper Ethernet ports. This is our standard on the Orion I/O, 2 copper gig Ethernet ports. We will discuss other Ethernet port options. The suite of cards that are available on the Orion I/O consists of 7 different cards. The first 2 cards that you see there are both 16 discrete input cards. The difference is the first card is 16 isolated discrete input contacts that are not wetted. So again, so in your wiring design, you would need to make sure you have a 125 DC or 12 to 48 volts DC source to wet those contacts. On the other hand, The 16 discrete input wetted card provides the wetting voltage necessary internally and sourced by the Orion I/O. Next, there are two options for discrete outputs. Both cards have 16 isolated output circuits, but the high power output card, fourth one there, handles an inductive kick up to 10 amps at 140 volts DC at 40 milliseconds over R. So if you're looking at applications where you're wanting to remove those ice cube relays from the design, then the high power output card is probably what you want to go with there. Next card that you see there is going to be a combination card where you would have 8 non-wetted discrete input statuses and 8 high-powered discrete output contacts. We'll actually spend a little time on that a little later. And the last two cards that you see there are going to be for 8 analog inputs. Both cards have 8 isolated DC analog input circuits with the ability to do a -2 to 2 milliamp range, -10 to 10 volt range, and 4 to 20 milliamp range. And both of these cards have less than a 0.1% full scale accuracy. We'll talk about some of the differences in the analog input card and the analog flex card. But primarily, the difference is going to be how you're going to be able to land those wires on those terminals. So for all the 7 different cards that I just mentioned, we like to make at NovaTech we like to associate type numbers with those cards. So if you're looking at a part number or picking a default file in the NCD configuration tool, then you'll have an idea where those numbers come from. So a 16 discrete output card, as you see there, is a type 0 card. A 16 discrete input card is for the 16 discrete input card that's non-wetted is a type 1 card, and so on. So if you go a little lower, the combination card is a type 5 card. The 8 analog input flex card, as you see on the bottom, is a type 6 card. So as new cards get introduced, we'll actually probably have type 7, type 8, and so on. So keep this reference in mind as you're working with the Orion I/O or building a part number or whatever the case may be. If we took a closer look at the analog input flex card and how it differs from the original 8 analog input card, you'll see the terminal design is different. Notice that with the flex card, you can land the shield wiring on terminals 1, 2, 5, or 6 because these are internally tied together and routed to ground. And you can just land your first positive and negative analog input signals to terminals 3 and 4, and your second analog input status, positive and negative terminals, will go on 7 and 8. Keep in mind you have 4 of these terminals on that card, on that analog input flex card. On the original 8 analog input card that we had designed, you actually had to make sure you land the wires based on whether you wanted a -2 to 2 milliamp, a -10 to 10 volts, or a 4 to 20 milliamp. So that kind of took up a lot of the terminals in terms of where you're planning on landing those ranges. But on the flex card, that range selection is 100% selectable in the configuration using a drop-down selection. Johannes will demonstrate that a little later. We have also, one of the things that we've added to this analog input flex card is the ability is actually increasing the impedance on the flex card for the -10 to 10 volt range from 10 kiloohms to 1 megaohm. We did that for some retrofit applications. Another enhancement that we've added to both actually both the analog input cards is the ability to have engineering scaling. So originally we had, we had the ability on the LED display to display the user-defined name. So in this case, trans top oil temp, and then we see the raw value that's being read in on that analog input signal. Now, you have the ability to also see an engineering scale of the value based on that scaled value, based on that raw reading that you're getting. So that is an enhancement that we've added to both the analog input cards. The next card I want to dive into a little bit more detail is going to be the 8 discrete in, the 8 discrete out combination card. As you can see, this little screenshot there is from the configuration tool in NCD. One of the things I want to point out is notice that for each of the cards, whether it's 16DI or 16DI wedded or so on, notice the types that are associated with those cards are also indicated within that default file. So keep that in mind. That's kind of what I was mentioning earlier with the numerical type association. So keep that in mind. But again, if we dive a little bit more into the 8 discrete in, 8 discrete output card, one thing you'll see on the front of the Orion I/O are the sets of LEDs there. So the first 8 of the LEDs are going to be green LEDs for those discrete inputs. And the second set of LEDs there on that same card slot are going to be red LEDs for the outputs. Like I've mentioned, this combination card offers non-wetted discrete input contact. So again, this is non-wetted. And then it also offers the 8 high power output contact. So make sure to keep that in mind during the design stage, whether you need to provide a wetting voltage source and whether you need your relays or not. Two primary reasons for the design of this particular card, I would say the first reason is to offer users the flexibility with their point count. So maybe rack space is a premium and you'd rather have 8 discrete inputs instead of 16 and add in some additional outputs. That kind of gives you that flexibility. The second primary reason is for an application we like to call feedback dropout for breaker control. This feature was designed into the card because it really is good practice to avoid misoperations due to time settings. So what we're going to do is we're going to go through a simple simulation of feedback dropout just to make sure everybody understands what that looks like. So this is kind of showing you a feedback. What you're seeing here on this slide here is going to be the Orion I/O 8 discrete, from the Orion I/O's perspective on the left-hand side. And what we have is a combination 8 discrete input, 8 discrete output card. Notice the output contact, one of the output contacts on the top-hand section, and then one of the input contacts up towards the bottom. Normally, if you're doing the wiring to a circuit breaker, you might have, on the right-hand side, you'd have the circuit breaker. And then with that, notice there's a 52B contact that's there. That's actually mechanically connected to the breaker. That contact will actually be wired into the input one of the input statuses on the Orion I/O, on that 8 discrete input, 8 discrete output card. So starting condition, let's just have, our output is open, input is on, our circuit breaker is also open. So at which point, when the output contact on the Orion I/O is closed, after a certain amount of time, that circuit breaker will actually close as well. Contact will close. Energized. When that's energized, the 52B contact actually opens up, and turning the input contact on the Orion I/O into the off position. When it does that, that automatically forces that output contact off. So output close command only turned on long enough to close the breaker. So that's one of the big benefits of this application. So keep in mind, you don't have to utilize this application. It is 100% optional. In the configuration, as Johannes will show you a little later, you could actually pick which input is associated to which output in terms of feedback dropout. So you'll take a look at that a little bit later in the configuration side of things. If we talked about the discrete output power, the 16 discrete output high power output card, I just wanted to make sure you got that we mentioned that that particular card has inductive break capability up to 140 volts DC. Break inductive circuit of 10 amps with a time constant of 40 milliseconds L over R. And notice the off to on to off times of 5 to 8 milliseconds. And it's also important to mention it's got a little bit of leakage current, about 1 milliamps or less. Aside from that, the other specs of that discrete output contact are going to be similar to our standard 16 discrete output card. So that means 2 terminals per output, and it's got a make and carry of about resistive of about 30 amps, and then continuous carry about 10 amps there. Next, I want to dive into a little bit about the wetted card. Again, there's a lot of detail here on this slide, but just want to make sure we mention a few of them. In terms of the wetting voltage, again, on the left-hand side, what you're looking at essentially is the internal of the Orion I/O 16 discrete input wetted card. And notice internally, we provide 24 volts DC or 48 volts DC. That's going to be generated internally by the Orion I/O. The voltage range is going to be software selectable. The card can survive 125 volts DC if it's accidentally applied to the external as an external wetting voltage. And this is essentially a group of 16 statuses that's on that card. In regards to inputs, the discrete inputs, continuing on that line, the conventional way of the LEDs is going to be when the LED is going to be in the on position when the contact's closed, and then when the contact is open, that LED is going to be off. That's going to be conventional. But whenever when utilizing the input state inversion, all that is, it's going to be basically a checkbox right next to the discrete input point in the configuration. So if you choose to select that input state inversion, what happens is when the contact is closed, that LED is going to be off. But when that contact is open, that LED is going to be on. So basically, it's going to be an inversion of that LED state. And Johannes will demonstrate that a little later as well in the configuration process. Next, I want to get into the Ethernet port options. So by default, like I mentioned, the Orion I/O comes with 2 copper Ethernet ports. Those are gig Ethernet ports. One of the options that are available on the Orion I/O currently is going to be the EP network option. Basically what that is going to be 1 copper Ethernet port, and then it's going to be 1 gig SFP port. With that gig SFP port, we have some options that can be ordered when you order your Orion I/O. These SFP ports, the SFP ports that we currently have available for the Orion I/O, they're just gig SFP ports, so if you have another one, it probably would work. But the ones we've tested and make available for customers are going to be 3 different LC fiber connector ones. Notice 1 is going to be a multi-mode and 2 are going to be single-mode SFPs. And then the 4th SFP that's available currently is going to be a copper Ethernet port. Again, these are all gig SFP ports that are available. Another option for the Orion I/Os is going to be an Ethernet switch option. Essentially, it gives you 3 ports that function like an unmanaged switch. And so here in this case, you can see there's the labels ETH0-1, ETH0-0, and ETH0-2. So these 3 Ethernet ports there are essentially 1 switch. And then you have ETH1-0, which is by default on a separate NIC. So it could be, maybe it could be set up on a different network for a particular application. So a couple different applications might be in regards to that 3-port unmanaged switch is if you want to daisy chain your Orion I/O. So you know, if you didn't want to run everything up to to a switch or even have a switch in the station, maybe you have a small substation where you know you have 2 or 3 Orion I/Os in the design. Essentially, this switch option allows you to kind of daisy chain those and you know have a simplified design. So that's one option there. Another option. Another application where that unmanaged switch comes in really handy is, you know, if you're using the Orion I/O in a, you know, client application where it's talking to a device. Like I mentioned earlier, it's got protocols like DNP, Modbus, IEC61850 that you could use to talk to other IEDs, protection devices, or if you're in a transfer monitor situation, you could throw that Orion I/O there and talk to a device or two. Again, you have some limitations in terms of point count, but and connectivity. So if you know, keep in mind you only have one serial port, and then you have that unmanaged switch there, and so you have some kind of limitations to kind of keep it in mind. But aside from that, it can work in that type of application. This is on a larger application basis. You might have you know, a large substation that maybe you would like to have 2 Orion LX plus RTUs communicating in a redundancy fashion, connected to you know, network switches, and maybe you have also Orion I/Os in that application. In this type of larger application, redundancy is a you know, could be common, and then you could also cascade those multiple Orion I/Os like I mentioned earlier. What this allows for is for the user to have one configuration file that's a redundant configuration file that you would load into the primary unit. That config file would be sent over to the secondary Orion LX Plus RTU. In addition to that, that would also send configuration files down to your cascaded Orion I/O modules. I think Chi has covered a bonding and bridging power hour. So we won't dive into it as much here, but if you choose to use that application where you have 2 networks and you choose to bond those Ethernet ports to aggregate those 2 networks, so that application is also available on the Orion I/Os. So the whole application of bonding 2 networks or bridging your physical 2 copper Ethernet ports, that's also available on the Orion I/O Ethernet ports. For those of you guys, just a quick reminder of what that is in terms of bonding and bridging. Bonding is basically allowing multiple network interfaces into a single interface for redundancy application possibly and improve performance. So that is going to be on the bonding side of things, but bridging, so those 2 terms keep in mind. So bridging is going to be actually taking multiple of those physical Ethernet ports to act as an unmanaged switch. So all the, you know, so on the Orion I/Os, both Ethernet ports would act like one on the same network. So we've done an intensive power hour on bridging and bonding and how to set that up and the different types of mode for bonding. So make sure to look at that. I've added the link at the bottom of this power hour. If you guys need that, let me know, but that's a good session there to understand bridging and bonding of those Ethernet ports. Next, I wanted just to touch on the IRIG-B capabilities of the Orion I/O. So the Orion I/O could accept unmodulated IRIG-B signal. Some techniques of synchronizing the time clock on the Orion I/O are going to be using, if you're doing Ethernet, you could use NTP, network time protocol there. The Orion LX Plus RTU or the Orion RTU can serve out NTP time to the Orion I/Os if that's the way you want to run it. You could also run the IRIG-B signal directly to the back of the Orion I/O like I mentioned earlier. So if you just wanted to use T connectors and kind of wire the positive and negative signals to the back of the Orion I/O. So those are probably going to be the 2 common ways of getting IRIG down to the Orion I/O. But if customers want to use a serial connection from their RTU down to the Orion I/O, they could also send the IRIG-B signal down from the RTU using RS-232 serial communications. They could also use the RS-485 communications to send the IRIG B signal to the Orion IOs. So you have, NTP as a network option. You have some serial options for getting IRIG B down to that Orion IO, or you could just, if you wanted to use T connectors and wire directly to the back of the Orion IOs, that's also an option as well. And keep in mind that LED on the front, or that button, the touch sensitive button on the front, when it says time, if you touch that, that'll give you indication if you do have a good time sync, if there is quality, and what the Orion sees as a current time and date. Next, I just wanted to hit on mounting options. So traditionally, the Orion IO is a rack mount, but we have been looking. We do have some options for surface mount. So this is one of the surface mount options on the Orion IO, where we have a custom essentially mount, where on the right-hand side it's kind of a hinge. It's a hinge essentially. On the left-hand side, it's basically two screws that would kind of mount that in. But if you ever needed to get access to the back of that Orion IO where all the connectors are, you could unscrew the two screws on the left-hand side, basically be able to gain access to the back that way. So this is one of the options for surface mount on the Orion IO. We are looking at, we do have some development plans to do a true surface mount Orion IO as well. Plan is to kind of have this available for DistribuTech 2022. But essentially with this design, all your connectors would be on the front end of the Orion IO, and then you would also have your LEDs on the front, as well as your power supply, your Ethernet ports, your serial port as well. So all in your maintenance port. So all that would be on the front side, so that you could do a true surface mount on the back. Again, this would basically get rid of that advanced LED display, but it is nice to have this for some applications where you're limited in terms of rack space. In regards to retrofit, so we've done a whole session. We've done a whole session on Power Hour on retrofit applications with the Orion IO. So I'll put that link down towards the bottom there. And if you go to our Power Community website, Johannes will touch on that a little later, but you'll see all the Power Hour videos there. But just wanted to quickly touch on that as well. So traditionally, if we just looked at a D20 application where as a legacy RT retrofit, traditionally you would have a proprietary protocol connecting one module to another, kind of as you see there. In a retrofit application, we would get rid of that processor unit, put in an Orion RTU at the head end, and the user would have their choice of protocol and their choice of serial or Ethernet to connect to the I/O modules, the Orion I/O modules. So if we just looked at the typical rack mount for the D20s, we would have interface boards right below the Orion IOs, which are 2 rack units. So that's essentially it's going to be the same size as those D20 IO modules. So this is just one example of some of the retrofits that we've done. So if you looked at an example of that, you would have an Orion IO with this type of adapter board on the bottom, where we bring out to the front the DB25 connections, we bring out the the network connections, the serial connections, and then the power connections as well. Again, this is going to be for a D20S retrofit module. Again, on the back end, all of this would be pre-wired and connected to the back of the Orion IO. Again, we've done retrofit applications we've done adapter boards and different types of designs for Landis & Gear, Telvent, Systems Northwest, D20. So if you have any of those legacy applications, please let us know, and definitely look at us trying to assist you with that and giving you an idea of what we could do there with the Orion IOs. At this point, I'm going to turn it over to Johannes and to do a little bit of the configuration side of things, and then we'll go into some frequently asked questions. Johannes, can you hear me?
Yep, I can hear you.
Okay.
Go to the next slide. Good morning, everybody. Before I get into the frequently asked questions, there's one question that just came up on the webinar. Can the Orion I/O handle dual power inputs? No. The Orion I/O has a single power input. That could be AC or DC. Can the Orion I/O card be upgraded or changed on the field? Yes. The I/O card can be upgraded or changed on the field. We do have customers that are currently doing that. And we have a documentation we can send that will help with that. Is the Orion I/O shipped with a config file? That's another one of the common questions we get. Yes, the I/O is shipped with a standard config file. But if you do want the Orion I/O to pull another device, you'll have to upload that config file and modify it. Or if you want the I/O to communicate to your RTU with a different protocol than DMP, you'll need to modify it. What is the power consumption of the Orion I/O? Approximately is 20 watts, but that could be a little different at the startup on the inrush power. Does the I/O need to be ordered with AR to capture status changes? No. The syslog can be used to capture any changes, but the problem with that, the syslog is, one, it's not easy to find the changes because the syslog captures everything that happens in the Orion I/O. The second thing is when the syslog is full, it's overwritten. So it's not a true archive. But I will show how to set up the syslog in the Orion I/O when I do the configuration on NCD. On the low voltage DI card, the one that's from 12 to 48, what is the minimum voltage input needed to turn that input on? It's above 9 volts. Anything above 9 volts will turn that contact on. What is the benefit of cascading Orion I/Os? Well, without cascading, you're going to have a config file for the Orion, and you're going to have a config file for each I/O. So if you have a cascaded 10 Orion I/Os, you're going to have 11 configuration files. So that's one of the benefits. And the second one is if you're not doing cascading, you're going to have to map between the master and the slave, or between the Orion I/O and the Orion LX. So you'll need to do, if you're doing DMP, you'll need to configure a DMP server and a DMP client and map the points. If it was cascaded, the points are already mapped, so you don't have to do that anymore. Can an existing standard NCD file be converted to a cascaded file? Yes, it can. So if you go to NCD, go to files, we have a tool to convert from a standard cascaded file to a client or server. How many I/Os can be cascaded at the same time? Like Ayo mentioned, we have tested 40 cascaded Orions, and that was one of the tests we performed a little while back. We had a configuration where we had set up 40 Orion I/Os on a cascaded with a redundant Orions and 256 DMP IEDs at the same time. The actual test included 40,000 points, 30 cascaded Orion I/Os, and 10 cascaded Orions, 256 DMP IEDs that were archiving 1,000 points every 50 minutes. We have a bunch of Lua and custom HMI screens and a direct video plugged in where 3 different clients were simultaneously browsing the Orion, and it only used 7% of the Orion power. So it's a very good test, and we have this test available. If you want to see the report, we can send it out per request. Now, going to configuration. To configure the Orion I/O, we use NovaTech Configuration Director. So we go to File, New. While I'm doing the Orion I/O.
Johannes, I think you want to share your screen.
Oh, I'm not sharing?
Not yet. I'm still in presenter mode.
Okay, sorry about that. Can you see it now, you?
I can see NCD, yep.
Okay. So I'm going to do configuring the Orion I/O at the same time I'm doing cascading. So if I'm doing cascading, the first thing I'm going to do is configure the RTU. I have an Orion LX Plus here, so I'm going to select Orion LX Plus, and I'm going to do cascaded. So select cascaded NCD file and hit OK. So you could change the description or the name. So I'm going to call it Orion LX Plus, and you'll need the IP address of the Orion LX Plus. Mine is 0.6, and I'm going to leave the TCP port as is. You have the option to use SSL, but if you are doing this configuration in a substation, the Orion and the IO, everything's in the substation, I would suggest or recommend not to use SSL because it would require a little bit more work to set up SSL. So I'm going to uncheck this and hit done. Then I have my Orion LX. Now I can keep adding the Orion IOs. So the first one, I'm going to do add server, and I'm going to have an Orion IO. I have a basic Orion IO with advanced user interface, so I'm going to select that and hit OK. Out here, you're going to put the description Orion IO _1, and the IP address of my Orion IO is 192.168.0.139. And I'm going to leave the TCP port as is. Now I have my Orion IO created. The next thing I do is I'm going to populate the serial port, network port, or I'm going to go ahead and create my IO cards. So I'm going to go to hardware IO, IO cards, click on add a new card. So we have all the available cards listed here. I'm going to start with a 16 DI, and I'm going to accept. So you have the action to do low or high. The low is from 24 to 48, I believe, and the high is 125 for DC. 12 to 48, 1 to 48, sorry. I'm going to do high. And then when I go to inputs, it shows me all the available inputs from that card. And for each input, there's an associated counter that counts up anytime there's a change. We're not going to the counters, we'll just go to the inputs. So you have your point numbers, your caption, your type, and the messages. So you have the option to change the message to whatever you want it to be. So if this is a breaker status, you could just say breaker stats, and then the off message, you could change that as well. So for 0, you want to say it's open, you could put open there. And then when it's 1, we want it to say closed. And you'll explain there's an option to invert the LAD on the front. You could check on that if you want to. If not, when it's on or when it's 1, the LAD will light up. If you want to see what this looks like, you can click on the preview. The preview will give you what it will look like when it's in the Orion IO. So the only card that I configured is card A. So if I click on the first point, this is what I put in, breaker status. You can put whatever you want. It has the timestamp on it, and then it's open or closed. So that's basically what it takes to configure the regular DI card. And if I want to add another card, the wedded is the same as the regular DI card, so I'm not going to do that. The DO or the output card, hit accept. And then I'm going to go to inputs. I have 16 output status points that I can use to monitor the output contacts. If I try to map them in, it won't let me because the outputs are not configured yet. But if I go to outputs and then map the outputs, now I can go back and map the output status. If I go back to outputs, on the outputs you have the point name, the channel, and then you have the type. So right now they're all configured to be pulse, but you have the option to make them pulse, latch, or trip close. If you want to make a trip close, first it won't let you do a trip close because trip close uses 2 outputs. And you see right here, I already configured output 2. if I'm going to configure output 1 to be trip close, it automatically uses output 2 as part of output 1 for the trip close pair. So I'm going to hit OK, and then I'm going to map out output 2. Then I could change the type to be trip close. You can also change the caption to say whatever you want it to say. That is the DI output card. The DO, or the output card. The next card I'm going to try, or I'm going to add, is the AI card, because the HPO card is the same as the DO card. I'm going to select 8 analog inputs. That's a regular card, and hit accept. And I'm going to go to inputs. I have the 8 analog inputs from that card. I'm going to map those points over. You have the description. You could change the point name, by the way, in any of the cards you want if you don't want to see analog point 1. If it's temperature, you can say temperature. The type is analog, and you have the option to change the transducer input. So we support -10 to 10 volts, -2 to 2 milliamps, or 4 to 20 milliamps. And you could change the caption to whatever you want. So I could say, this is temperature monitor, for example. And then I can give it the scaling. I could say 0 to 65535. And I can give it the engineering unit. I could say it's degree. Now, when I view the preview, I see I have the B card already configured, and then I have the C card, temperature monitor, degree, and volt. That is what I put in here. And that's how it's going to show up in the Orion I/O when it's running. The next card I'm going to configure, the AI flexible, is the same as the AI card. I'm going to do the combination card, the 8 digital outputs and 8 digital inputs, and I'm going to hit accept. Go to inputs. So as you can see, I have my 8 digital inputs, the 8 counters associated with those digital inputs, and then the 8 binary output status for the 8 outputs that come with this card. So I'm going to map in the 8 digital inputs. Nothing changes, similar to how we did the first DI card. I'm going to go to outputs. I'm going to map in the 8 output cards. But on this card, what's different is, like you mentioned earlier, you could set up your feedback input card. And so for output 1, if I want to use the feedback point to be output 1, binary input 1, this trip close is what it needs to be. I'm going to take output 2 out and then make this trip close. And then, sorry, it should be output 1 right here. So the feedback works on a trip close. So output 1 is tied to output 2. Now I could tie it to binary input 1. Sorry about that. So I took output 2 out, then I configured output 1 to be trip close. Then I could do the feedback on binary output 1. And that is how you configure the Orion I/O card. Now, when I go to my Orion LX Plus, since we did cascading, and I'm going to go to network, I'm going to configure a new port. Now the Orion, this is going to be a slave port, so it's going to be DMP3 server. I'm going to hit OK. When I do add the new RTU and go to inputs, all those points that I just configured on that Orion I/O are already mapped in. So I don't have to configure a DMP slave or DMP master port. So I can go in and filter it by the I/O. So as you can see, I have my 8 cards and the count field card for the count field for the B. So each I/O card has a count field point, and the whole Orion I/O has a count field point as well. So if you are communicating, if the Orion is communicating with the I/O, you can monitor the whole Orion I/O count field point, or you can monitor the per card point. So I'm going to go ahead and select the points I'm interested in and then move those over. So now I configured the Orion I/O and I configured the Orion LX Plus. It's ready to be downloaded. But before I do that, I want to show you guys how you do the syslog to capture point changes on the Orion I/O if you don't have AAR. To do that, I'm going to go to the Orion I/O, I'm going to go to Add-ons, and then System Logger. So you can go to General and then Options, and I'm going to do Log all digital inputs and hit Accept. And I'm going to go to Inputs, and all those points are already mapped in. So anytime this point's changed, it's going to be logged in. So I have this configuration file already running in the Orion. First, let me go to the slave port. This is the Orion I/O. On the Orion I/O, first thing you need to do when you're doing cascading is to go to Settings and Cascading Slave, and you'll tell the Orion I/O what IP address is the cascading master or what the RTU is. So the RTU we're using is 192.168.0.6, and I'm going to leave the TCP port as is. Then you hit Save and Make Active, and then you will have a save.ncd, slave.ncd running on it. So when you make the configuration file active, this is the Orion, the master Orion, it automatically sends the slave Orion or the cascaded Orion I/O's config file to the Orion I/O. And the description is going to be CSD device 1. If you have a second Orion I/O, it'll be CSD device 2, and then so forth. If you go, I'm going to go change a point. I'm going to go to the Orion I/O. I'm going to go to data values. I'm going to make a change on the DI. I'm going to change binary input 1 on card A to 1. Now, when I go to the logs, as you can see, it logged it. So it logs everything else. That's a problem with using the syslog. It logs everything that happens on the Orion LX. If you change it on the Orion I/O, you change the config file, change the password, change an IP address, everything is logged. So if you want to monitor the point that changed, you'll have to go through and figure out which one was changed. But this is the one that I just changed. First, it tells you NovaTech forced point binary input 1 at card A, and then it tells you it went from 0 to 1. And that's how the syslog works. And that's how cascading works. Ayo, can you put up that PowerPoint again?
Yeah, give me 1 second.
All right. Go towards the end. Next page.
One thing I was going to mention while online was that what you was just showing, again, the alternative of not using alarm archiving would be syslog. It is still logged for you, but if you wanted true sequence of events, we could also do alarm archiving on the Orion I/Os. So keep that in mind.
And one thing that came up, sorry, before I get to that, there's a question that came up. Can the Orion I/O get time from the master through cascading? No. I know in DMP you can set up time through the protocol, but the Orion cascading protocol does not support that. So if you want to send time to the I/O, will have to be iReg or NTP. Go to the next page, yeah. So that was our webinar for today. We do want to mention that you can sign up for power.novatechautomation.com, where you can get all our previous webinars, documentations, applications, anything that can help you configure the Orion. And with that, we also have a booking app at booking.novatechautomation.com, where you could book half an hour with a sales engineer to talk about anything. We could do support, or if you want to talk about cascading, Orion I/O, anything else, we can help with that. So me or anybody else in our group is available through the booking app. That was our webinar for today. Thank you for joining us, and talk to you soon.